Dear students, let us start now the next important compound of boron, which is called as borazine. So, borazine is a colorless volatile liquid compound having molecular formula B3N3H6 and which is formed by heating of diborane and ammonia, and its structure look like that of benzene with alternating boron and nitrogen atoms in a ring. So, it is also called as triborine triamine. So, boron is an inorganic compound which has a chemical formula BH3 twice, NH3 twice. So, in this cyclic compound, the 3 BH units and the 3 NH units alternate each other. The compound is isoelectronic and isostructural with benzene, since it looks like benzene and it is a colorless liquid. So this is actually the structure of borazine, which looks like the structure of benzene. So it can be also called as inorganic benzene. Here you can see in this structure there are alternate units of BH along with NH bonds. So borazine is isoelectronic with benzene and it has a similar connectivity, so it can be referred as an inorganic benzene. So this comparison is not rigorously valid due to the electronegativity difference between boron and nitrogen. So crystallographic structural determination shows that the bond length within the borazine ring are all equivalent at 1.429 angstrom unit, a property shared by benzene. So the electronegativity of boron is around 2.04 on Pauling scale compared to that of nitrogen is 3.04, and also the electron deficiency on the boron atom and the lone pair of electron on the nitrogen favor the alternative mesomeric structure for borazine. So boron behaves as a Lewis acid and nitrogen behaves as a Lewis base. So these are the three mesomeric structures of borazine, which can be written with the arrow headed with both the sides. So this borazine is synthesized from diborane and ammonia in 1:2 ratio at around 250 to 300 degrees centigrade with a conversion of 50%. That is 3B2H6 plus 6NH3 giving 2B3H6N3 plus 12H2. An alternative and more efficient route begins with lithium borohydride and a reaction of lithium borohydride and ammonium chloride. That is 3LiBH4 plus 3NH4Cl, which is B3H6NH3 plus 3LiCl plus 9H2. In two-step process to borazine, boron trichloride is the first converted into trichloroborazine, that is 3BCl3 plus 3NH4Cl giving Cl3B3H3N3 plus 9HCl. The 3 BCl bonds are subsequently converted into BH bonds. So this can be done by treating the boron trichloride with sodium borohydride, and we can see this is a conversion wherein the BH bonds are converted, the BCl bonds are converted into BH bonds. So although often compared to the reactivity of benzene, borazine is far more reactive with hydrogen chloride and it forms an adduct, whereas benzene is an unreactive towards hydrochloric acid. So B3N3H6 plus 3HCl giving B3N3 H9Cl3, addition reaction of Borazine with hydrogen chloride. So this product, so when reacted with the sodium borohydride, it gives these reduction. On reduction with borohydride, it gives BH4N thrice. So in addition, the addition reaction of bromine does not require any catalyst. Borazine undergoes a nucleophilic attack of boron and electrophilic attack of nitrogen. So heating of borazine at 70 degree expels hydrogen with the formation of borazyl polymer or polyboroxylene. So in which the monomer units are coupled in para position by new boron nitrogen bonds. Boron nitride can be prepared by heating polyboroxylene to 1000 degrees centigrade. Borazines are also starting material for other potential ceramics such as boron carbonitrides. So this compound was first synthesized by Alfred Stock and Henrik Pollard, Poland by reaction of diborane with ammonia. So that is in 1:2 ratio at 250 to 300 degree with a conversion ratio of 50%. 3B2H6 plus 6NH3 giving 2B3H6Na3 plus 12H2. An alternative, more efficient route begins with sodium borohydride with ammonium sulfate. 6NaBH4 plus 3NH4 twice SO4 giving 2B3 and 3H6 plus 3Na2SO4 plus 18H2. In two-step process, boron trichloride is first converted into trichloroborazine 3BCl3 plus 3NH4Cl giving Cl3B3H3 and 3 plus 9HCl. The BCl bonds are subsequently converted to BH bonds 2Cl3B3 and 3H3 plus 6NaBH4 giving 2B3H6 and 3 plus 3B2H6 plus 6NaCl. So the electronegativity of boron is 2.04 on Pauling scale compared to that of nitrogen is 3.04, and it is also the electron deficiency of the boron atom and the lone pair of nitrogen favor the alternative mesomery structure, which you can shown by the following structures. Boron. So due to similarities of benzene, we have got a number of computational and experimental analysis of borazine's aromaticity. The number of pi electrons in borazine obeys the 4n plus 2 rule, and the boron nitrogen bond lengths are equal, which suggests that compound may be aromatic. The electronegativity difference between the boron and nitrogen, however, creates an unequal sharing of charge, which results in the bond with a greater ionic character, and it is expected to have a poorer delocalization of electron than all the carbon analog. So therefore we can tell borazine with high standard enthalpy change of formation, that is about minus 531 kilojoule per mole, which makes it thermally very stable. So with this we can conclude for borazine, which is an important, once again important compound of boron, a non-metal. Thank you.